Welcome to all. Let's see about the demonstration and implementation about my IBM project. And my project title is about a power nutrition analyzer for fitness industry. And then let us see about the objective. The main aim of the objective is to build model that display nutrition content present in the food depend on fruit color, shape, and texture. In our daily life, there is a lack of nutrition which include cardiovascular disease and depression and obesity. In order to avoid this, we got to include nutrition content in our daily food. Then we have a solution about the problem. The solution is to develop a power nutrition analyzer for application by giving the input image as in fruit or vegetables as an input to the application. It will display nutrition content present in it. Then we see about the prerequisite for this implementation. We have to install Anaconda Navigator with Flash framework. Then we go to include Python package such as NumPy, Pandas, TensorFlow, and Keras package. We have to implement machine and deep learning concept with CNN architecture model. Then let's see about the empathy map. In empathy map, then what we hear about the project and what we want to do in the project, and let's see about the project and what are the gains after we implement about the project. Then what we think and what we feel about the project. Then what is the ideation? We are group of 4 members. For an individual, there is an creation of idea about the project on how to implement in it. Based on that, we have a brainstorm idea that what are the implements we have to happen do in our project. As we conclude, as we have group ideas, we have developed nutrition with workout and programs to implement in this project. Then let's see about the solution architecture. In the solution architecture, we have developed the front-end tool, UI tool, both to computer and mobile phone. As a user given an input image, then an input image involving image segmentation process with CNN future learning architecture with trained image dataset, and which involving classification and which is stored in dataset with trained nutrition dataset and tested nutrition dataset. After that, it involving image pre-processing process which display the nutrition content about the input image. Then let us see model building about the dataset. And we have given the dataset, we have to import the drive. Then we have to move to the particular directory. Then we have to unzip the dataset which is in zip format. Then after that, we have to do image pre-processing from Keras package. From Keras pre-processing.image, we have to import image data generator. After image pre-processing concept, we have to make image data augmentation. In image data augmentation, we have 2 methods, train datagen and test datagen. From train datagen, we have to rescale the image to 255 pixels, and we have to make the shear range, that is slant of the shape, to 0.2. We have to make the zoom range as 0.2, and we have to make horizontal flip as true concept. Then in test datagen, we have to make to rescale as the image as 255 pixel. After that, we have to apply image data generator functionality to train set and data set. For that, here include xtrain and xtest. We have to make the directory, and we have to make the target size 64-bit, batch size 5, and we have to make the color mode RGB. Then the class mode as sparse categorical column. Then we have, it will display how many images present to how many classes. That means 411 images found belong to 5 classes, that means 5 folders, that means 5 fruit images. Then after that, you have to print what is the indexes present to it. Indexes apple to 0 and banana to 1 and orange to 2 and pineapple to 3 and watermelon to 4. After that, we have to make and build model. For building model, we have to import the necessary libraries as NumPy, TensorFlow, and in TensorFlow Keras, we have to import sequential and layer and dense and flatten and convolutional 2-dimensional layer and maximum pooling and dropout layer concept. Then after that, we have to initialize the model that we use classifier variable name to sequential library. After that, we have to add convolutional and maximum pooling and flatten layer concepts. After that, we have to adding dense layer. And dense layer, we have to include units 128 and with activation rule relu functions, and we have to add dense unit 5 with activation layer softmax. Then after that, we have to print the summary about the model building. It will display the convolutional layer and maximum pooling and what dense layer and flattened layer and dropout layer about the model. And then we have to make the configure the laning process. After the model building, you have to lane. It is an optimization, include an optimizer as Adam. Then we have to make a sparse categorical cross entropy with make the accuracy. After that, we have to make an epoch. That means we have to fit the model. For that, we have used an epoch. For epoch, we have used 20 epoches for unit. After that, we have to save the model. What we have to save the model means we have to use the classifier dot save file name dot h5. H5 is hierarchy. Then let's start with application building. As a result of model building, we get an output of nutrition.h file, which I loaded into the model. From for that, I import a Flask render template and request library from the Flash framework, and I import OS and NumPy packages as NumPy, and I install TensorFlow, Keras model, load model, and images library. It will display the home page, which include objective of the project, and it will display the aim of the project, and it will display the portfolio, which include demo video, GitHub code, and project documentation about the project templates. When I click the classify buttons, it will move to the next page, 127.0.0.1 colon 5000 slash image one page. It will show the upload image option to choose the file. If you click choose, after that it will move to the file manager, and we choose the particular image option means it automatically redirects, and it will show the image preview, which is in 255 pixel format. If I click the analyze button, it will check with the prediction with the tables, and choose the which image is an input images, and will tell nutrition present in the food from the rapid API concept, and will display the image formats, and which is the image is classified as, and will display the nutrition content in it. Available in the input images. And this is our demo about the project, and thank you for